So in this example, we've been asked to differentiate y equals a third x squared plus 5x sine x e to the 2x. Now it's a long function and you might be unsure of how to differentiate this. What we need to use is the product rule. Now if you remember our product rule from examples where we have two functions multiplied by each other, we sort of gave the general equation where y equals uv, and u and v represented the different functions. Now we're going to do exactly the same thing here, but in fact we have three different functions, so we need to first of all identify those functions. So we have one here, which is a third x squared plus 5x, and I'm going to call that u. What other functions do we have? We also have the sine x, and just like before, I'm going to call that v. But we also have an extra term. We have the e to the 2x, and that's multiplied all in our function, so I'm going to call that w. Okay, so just like we had in a product rule for two functions multiplied by each other, y equals uv, here we have y equals uvw. So what is our product rule for three functions? Well, if y equals uvw, as we have above, then our product rule says that dy by dx will be. So you differentiate the last one and you leave the first two functions alone. So it's u, v, dw by dx. Then you add. You differentiate the second one and leave the other two functions alone. So it's u and w we're leaving alone. U, w, and differentiate the second one. And then finally you add the differential of the first one and you leave the other two functions alone. So we have v, w, du dx. Now all that, u, v, dw dx plus uw dv dx plus vw du dx, is our product rule used three times, and if we can find all that, we can differentiate our function. We already know what u, v, and w are, so the things we need to find out are dw dx, dv dx, and obviously du dx as well. So we can start by doing that. So first of all, what did we say w was? We said w equals e to the 2x. Now using our exponential rules, you should be able to differentiate this directly. We'll get dw by dx will be equal to 2e to the 2x. You leave the exponential alone and then you just multiply by whatever the x is multiplied by. So we have dw by dx equals 2e to the 2x. And that one's nice and simple. Now dv by dx, what did we say v was? We said v was equal to sine x. Now you should be able to differentiate this straight up using your trigonometric identities for differentiation. dv by dx, or sine just goes to cos. There's nothing inside the bracket, so sine x just differentiates to give cos x. So we've done dv by dx. Now finally we have du dx. Well, what did we say u was? At the very beginning we said u was equal to a third x squared plus 5x. Now a third is just a constant, so we don't need to worry about that. But we know then that du by dx, we can differentiate this straight away as well, which should be a third. What does x squared differentiate to? Differentiate to 2x. What does 5x differentiate to? Just differentiates to 5. So we know that du by dx is a third 2x plus 5. So let us just recap what we've done so far. We established our three functions, which were u, v, and w, and then we found the derivatives of each. We found dw dx, dv dx, and du dx. And remember our product rule for three functions was if y equals u, v, w, then dy dx equals u, v, dw dx plus uw dv dx plus v, w, du dx. So we can input everything now. We know everything, so we can input it all into our equation for the product rule. So let's do that now. So we're going to have dy dx equals uv, well uv is a third x squared plus 5x multiplied by sine x, and now we're going to put in the differential dw dx, just going to maintain the colour code, and that was 2e to the 2x. Now we're going to add uw dv dx, so that is again a third x squared plus 5x times by e to the 2x. Then we're going to put in our differential dv dx, and dv dx we've already established was cos x. And then just going to write this one underneath because I'm running out of a bit of space. And we're going to add, so it's sine x e to the 2x times by du dx, which we said was, to maintain the colour code, a third 2x plus 5. So we've differentiated it, and you have now done it. So if you're asked to differentiate it and not to simplify it, that is completely right, and you have done it. But as mathematicians and as engineers, we like to simplify things. So is there anything we can take out as a common factor? Well, first of all, the first thing I can spot is all of them have a third in it. So we have a third there, a third there, and a third there. So we can take a third out. Is there anything else we can take out? Well, yes, there is. We can take out e to the 2x from this part, e to the 2x from this part, and e to the 2x from this part. So what I would suggest, if you wanted to tie this up, is take out a third e to the 2x. So we're taking out a third e to the 2x. Now on the inside that will leave us then, on the inside of the brackets from the first term we'll be left with 2 sine x squared plus 5 x. From the second term we'll be left with cos x squared plus 5x. And from the last term we will be left with sin x 2x plus 5. 2x plus 5. Now that is it differentiated and simplified. That is our answer. Now what you could do if you wanted to, but I'm not going to do it here, is inside this bracket we also have a common factor. This term has an x squared plus 5, and this term has an x squared plus 5, so you could take that out if you wanted to, but you could also take the sin x out from the first and the last term, because this has a sin x and this is a sin x. So you could neaten it up inside if you wanted to, but because not all the terms have one common factor, I'm not going to take it out. So I'm going to leave it in the form as it is, and that is our differentiated function completed.